Welcome, everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those who are still in the middle of connecting. Welcome, everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first, a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. But I want to provide an additional mechanism to ensure any questions we miss get answered. If you'll visit aka.ms/Azure Sentinel Community, you'll be able to ask questions on our Azure Sentinel forum. If you're listening to this after the fact as a recording, that's also a great place to ask a question. And any of these links I'm referencing here are in the announcement window in the sidebar if you need them. We always love to hear your feedback on how we can improve these webinars. You can give it at aka.ms/security-webinar-feedback. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Also, another way to connect with us is through our private preview program. You can get to that through aka.ms/security-private-preview. So we'd love to see you there. While you are there, please join our community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We've got a great topic for you today. We'll be talking about Azure Sentinel. Specifically, we're going to be talking about threat hunting, and we'll be revisiting that topic from a webinar we did a short while ago on that. I'd like to introduce you to our presenter, Pete Bryan. He is a security researcher in our Microsoft Security Threat Intelligence Center team, and so he has deep expertise in this topic. Without further ado, I will turn it over to him. Pete?
Thanks for joining us all today to hear about threat hunting with Azure Sentinel. Now, some of you may already be doing threat hunting, hopefully with Sentinel, perhaps with another platform. Some of you might be starting out with the kind of threat hunting journey, maybe trying to move from a reactive security posture into one that's a bit more proactive. So today I'm going to cover kind of the foundations of threat hunting and take you through some of the key features in Azure Sentinel that can really help you kind of drive and gain value from your threat hunting exercise. So the first thing to cover is, what do we mean by threat hunting? A lot of people refer to threat hunting in different scenarios, but how we think about it is the idea that you are proactively hunting through your environment for a threat or a set of activities that you have not previously detected. The not previously detected part is what kind of really differentiates threat hunting from, say, incident response or alert triage. You are not starting with a positive point. Instead, we're starting at the top of our cycle with our hypothesis. So this is the idea that we have to go find some activity. We then need to plan out what we're going to hunt for, and that requires us to understand where we're going to hunt and how we're going to do it. So that means we need to understand the data we have, the tools we have, the expertise we have, and work within that. Then the hunting cycle doesn't stop when we actually execute the hunt. There is still a number of phases we need to kind of conduct throughout the life cycle of it, including responding to anything we might find during our hunting activity. Even if we don't find anything, or we don't find an active threat to directly respond to, there's going to be some activities we're going to want to do out the back of the hunt. So this will include maybe setting up new monitoring, improving our detection capabilities, or just generally improving our threat hunting for the next time we do this. And again, the key with any good process is that it's a constant loop, and that we're documenting everything we do as we go through it, so that we can use that documentation for that improvement cycle. And again, as we go through, we'll talk about all of these stages and how they all fit together, particularly with Sentinel. So with that as our process we're going to follow during our threat hunt, there are also some other kind of foundational prerequisites that we need to have before we can start. Now, not everyone is going to necessarily have all of these before they start their threat hunting kind of journey. But if you want your threat hunt to be effective and repeatable and efficient, it's good to tackle these foundations first. And they broadly fall into two main elements. One is understanding what you're doing. So what is the environment you're hunting in? What does it look like? Now, if you're a SOC team monitoring and protecting an environment, you're going to have quite a good understanding of that already. But you also need to understand the threat you're hunting for. So in order to effectively hunt for something, you need to understand what it is you're looking for and how that's going to appear in your environment and the data that you have. So quite often when conducting some hunting activity, you will need to maybe simulate the activity in a lab environment to understand how it might look before looking for it in the real life. Or you may need to rely on research. And again, you can conduct this yourself or rely on the broader information security community out there. Things like blogs and particularly Twitter is a really good source of offensive security research that you can use to gain the knowledge to help your hunting activity. Along with that, you also need to make sure that you have the data to be able to hunt in. So this includes a depth of data, so data with the detail that you need to find the activity. So this might be enabling the right level of logging on your devices, but also the breadth of data. So having data from a number of different sources. That breadth is really important as we get into the hunt, because you're going to want to pivot from point to point. You're going to want to move through the attacker activity if you find any. And there's nothing worse than going through a hunt only to find that you have a black hole in some area of your network that you really need to see into. It's going to slow you down. It's going to leave gaps of uncertainty where you gather that data. So again, if you can ensure that you're collecting a reasonable range and depth of data in advance, you're going to save yourself a lot of time and effort later on in this process. So I mentioned at the beginning that threat hunting all starts with a hypothesis. So this is the idea of what we're going to hunt for. And really getting this right is pretty key, because it focuses everything that we're going to do during the hunting process. It's our focal point, it's our North Star. So again, it's worth spending time getting this right and kind of practicing developing these. But what makes a good hypothesis? Well, there's a number of factors that goes into it. However, the kind of key ones are keep it focused and keep it achievable. So don't go looking for a threat that you know you have no hope of finding because you don't have the data available, or you don't have sufficient knowledge about the threat to know how to find it. Similarly, don't try and look for something very, very broad. Having a hypothesis of, I'm going to hunt for strange logons. That is incredibly broad in terms of what that could mean and in terms of the time you're looking for. Are you looking for any login ever? Are you looking at the last week, the last day? Again, try and focus it down a little bit. The time-bounded piece also comes into the whole documentation side. Again, you're going to want threat hunting to be a continual process. If you don't time-bound your hunts, there is a chance that you will end up just repeating the same hunt on the same data set. So by time-bounding our hypothesis, you have a record to say, I did this hunt at this time, covering this period. So the next time you, or maybe someone else in your team, comes to it, they know that they can skip on to the next month or look at a different hypothesis, different threat. You also want to make it effective and efficient. So you want to target it on threats that maybe you don't have good coverage for in your detections. These might be things that you know that you've previously missed or that you haven't detected. Or again, a good SOC team typically has a good idea about where their coverage is good and where it is maybe a bit weaker and needs some improvement. You also want to make sure it relates to a realistic threat for your situation. There is no point hunting for a advanced threat that is targeting an industry you're not in or a platform that you're not using. So again, keep it related to the threat model that you're defending against. Otherwise, you can burn a lot of time on threat hunting for things that you will never find and are not really a threat. In the same way, don't start your threat hunting journey if you're just starting out by going after the most advanced threat possible. Start with the basics and build yourself up. Again, as with any good security practice, the kind of foundations are the key. So today we're going to take us through a threat hunt within our environment using Sentinel, and this is the hypothesis we're going to use. So we're looking for a malicious actor who has compromised the credentials of one or more of our Linux admins and has used these credentials to log in to some of our Linux infrastructure within this time window, kind of the week before last. So again, you can see this is quite achievable. It's very focused on our users and our hosts, and we've time-bounded it in a nice discrete window. So now we've got this hypothesis. There are a number of places we could start to look. So this is not an exhaustive list of starting points, but it gives you a good idea. Anomaly detection is a particularly good one. Are there kind of patterns of behavior related to the data we're looking for that just stand out? Maybe if you're looking to do a threat hunt for a specific actor activity, you might have specific TTPs or IOCs that you can use to start the hunt from. Or maybe if you know that you have a vulnerable system. So let's say the recent vulnerabilities that have been found in a number of VPN products. Maybe you want to do a threat hunt for activity that has compromised them. Well, we can then focus and start our hunt on those devices. And then the last one, top bottom focus. So this is one that I've used successfully in my career to find interesting things before. So this can be taking a data set of interest and just looking at the top 5 or the bottom 5%. So that might be you're looking for malicious applications running on your endpoint estate that hasn't been detected by your AV engine. Well, sometimes a good way of finding such applications is looking at what applications are running on less than 5% of machines within your environment. Again, you can apply that to other situations and other data sets as well. The last thing I want to show you before we get into the data and the Sentinel portal itself is this idea of a data matrix. So again, going back to the process chart we had at the beginning, we start by developing our hypothesis, but we quickly move on to reviewing the data we have available. Now, over time, you will start to build up a knowledge set about your data, and you can start recording this into a matrix like this. And what this is showing is in the data tables I have, what entities are appearing in them, and whether I have that data reliably. So when I come to hunting in future, I don't have to start from scratch with my data review. I can refer to my matrix and see that, oh, I'm looking for user activity. I have these tables with the account name in them, and they appear in these fields. So over time, this can really kind of save you some time and effort when starting a new hunt. So again, I would recommend trying to build up something similar to this, again, as you go. And it is not just useful for threat hunting, it's useful for incident response, it's useful for alert triage, it's useful for anyone using Azure Sentinel or a data set. So with that, let's jump into Sentinel itself. So again, there are a number of different ways to access data in Sentinel. I will try and touch on as many of them as possible, but really a lot of it comes down to personal choice. You don't have to use all the features. You can focus on the ones that are really kind of valuable and beneficial to you. The core, however, is the log data and the queries we have. So if I jump up here, this is my log view. Hopefully, if you've used Sentinel, you'll be familiar with this because it is the cornerstone of accessing data. So again, in this scenario, we're going to say that we don't have a nice, well-built data matrix, as I showed you in the last slide. So what we're going to need to do is look for data from scratch. There are a number of ways we can do this using the KQL language in Sentinel. So one that is a good starting point is the search star feature, which allows us to search across all of the data sets we have.
Pete, I'm sorry to interrupt. Would you mind maybe just zooming in or enlarging a little bit? I'm concerned people might not quite be able to read your queries there. Perfect. Thank
Brilliant.
you.
Thank you. So this top query is using this search star feature. This is an expensive query, but it searches across all the data sets we have for a particular keyword. In this case, sign, or it could be maybe user. So if I zoom back out, let's try user, and we run this. You can also see we're using the summarize command to group this data, so we get a nice kind of succinct data set out of it. So now from this, we can see we have a whole bunch of tables containing potentially user data. Our hypothesis was Linux admins on Linux infrastructure. So we can say that syslog is probably going to be a good one. But also we have some audit D data to use. Now, we're going to focus on syslog first of all. Two reasons for this is, one, we can more reliably expect all our hosts to be sending syslog. And two, it's a smaller volume of data. Audit D, whilst very detailed, can be incredibly noisy, and that can make it a bit tricky to search through. So we need to understand now what is in syslog. So we have two queries here: get schema and sample. So we've got get schema and sample. Get schema will show us the schema of the syslog table so that we can understand what fields we have. And sample will take 50 random items from that table and return it to us so we can get an idea of the data we might have. So schema is fairly straightforward for syslog. We get all the expected fields, but syslog message is going to be where the most interesting stuff is. And sample, we can see that now we have a whole bunch of different results. If we want to look at what is included in each one, we can expand it. We can start looking through. So now we have a better understanding of what data we're going to look for. We want to start looking for the threat. So in this case, we were looking for activity where an attacker has compromised one or more of our hosts by compromising a user credential. So what we want to look at is logons. Now, anyone who's used syslog before will tell you that one of the key differences between syslog and, say, Windows events is it's a lot less structured. You get a lot of data in the message, but it's not broken up into as many granular fields. So we need to do some parsing to pull out different elements of that syslog message, which we're doing here using some basic regex. So this section here, particularly, we're extracting username, we're extracting logon type, we're extracting source and source IP and source port, and expanding that out into separate fields. What we're also wanting to do is look at, are there any suspicious patterns or anomalies here? So we're using the summarize feature to group the results, and we're also using the bin feature. Bin allows us to bucket the results, in this case by 1 hour increments over the time we're looking at. So if we run this, we get a nice table of data, but actually to visualize it in a more effective way, we have the chart feature. So by selecting this, I get a visual representation of that same data. I can change the graph, and using something like a line graph, I can see actually I have a number of spikes here, and here. That starts to give me a bit of a focal point now for my hunt. I don't want to necessarily look at every single logon, but looking at the time periods where I have a spike might indicate some suspicious activity. I can also look at specific users. So if I had a user of, excuse me, if I had a user of specific interest, I could look at them. Here we're looking at a user, and we can see that we have 69 failures and 1 successful logon. So again, we could compare this to other users or previous time windows for this user to understand whether this is useful. If we suspect it's suspicious, what we could do is just look for that user's successful logons. Again, any Linux system that exposes a admin port to the internet is going to see a loss of failed logons. We probably don't care about them in the same degree as we do maybe a successful logon. So we can instead focus on these details. Now, again, at the start, I mentioned how important documentation was to threat hunting. And quite often during a hunt, you'll want to refer back to items that you discovered earlier in the hunt, or maybe in a previous hunt, just so you can reference them and see where they compare. A really good feature of Azure Sentinel to help with this is the bookmark feature. So let's say this successful logon, I don't necessarily think it's malicious at this stage, but I want to make a reference of it for later. What I can do is add that as a bookmark. That gives me the side view where I can say some notes about the bookmark and map some entities to it. So if we do that quickly, and if we map the user, so here we can choose the fields that contain the data that we're looking for. So I'm looking for source IP, and there we go. And I can, again, add some useful notes for me or another investigator later to come back to. So now I've saved that bookmark, I can continue with other elements of my hunt, or I can alternatively jump to the hunting feature within Azure Sentinel and look at that bookmark in more detail. So this is the one we just saved. I can see that I have all the details regarding it here. I can dig into the raw data, or I can use the investigate feature to get a visual representation of the bookmark. So again, if you're using Sentinel and you've seen alerts, you're probably familiar with this view, but you can also apply it to these bookmarks. And as with the alerts, I can pivot off of these elements and see that actually that strange logon behavior we saw coming from that IP or that successful logon coming from the IP has also been associated with some attempted SSH brute force alerts generated by Sentinel. We can also see that that machine has had a number of attempts against it. So this is now giving me a much better idea that that successful logon might not be as benign as maybe we first thought. By expanding further, we can also see that there's another host in our environment that has potentially been affected by this, and another IP address that might be involved in this potential attack. So this graph has given us a very easy way to expand our hunt and given us a number of other useful variables to go look into and dig into. Now, we can continue to use the investigation graph or the KQL queries in the log view to dig into our elements a bit more. However, one of the really powerful features of Sentinel that I like to use for hunting is the notebooks feature. So if you're not familiar with the notebook feature, what this is Azure Sentinel's integration with Jupyter Notebooks. These are interactive browser and code-based environments that allow us to effectively run a number of queries, data analysis, and visualizations. They're really powerful in terms of data science and really useful for hunting. Now, they require some development and coding knowledge because they are code driven, but we have produced a number of notebooks to help investigate or hunt on common entities. So you can see here we have one for a Linux host, which allows us to specify a host name and look at the data from that host. Now, in that log query and investigation graph, we identified a number of hosts that we maybe want to hunt in a bit more detail. So I can load up this notebook and start digging in. So simply clicking on the notebook will take me through to a number of setup steps for Azure Notebooks, our kind of cloud-based instance of Jupyter Notebooks. As this is a webinar and I wanted to save some time, I've kind of pre-done this to save us some steps. So I can just jump straight into this notebook now. So again, this notebook provides me with a number of sections I can look at related to maybe if we look at host logons, user and application activity, or network activity. So using this notebook is very easy. I have a number of these cells populated with code, and below it is an area that includes the output. To run these cells, I simply select them, and I can either use Shift or Enter, or the Run button up here to run them. Now, there are a number of kind of setup and authentication steps at the start, which I've kind of pre-populated to save us time here today. So we can kind of jump into the interesting bits. So here we have a cell that just allows us to kind of pick a time window. So again, you can see we've got the input as a code block, and then the output in this case is a widget where we can select a time window we want to look at maybe. So our hunting hypothesis window. And run the next cell to select a host. And what this is doing is querying the data set in Sentinel for me and bringing back results. So here we have a number of queries looking at data regarding a host and bringing back a summary of that host for me to give me some context. So again, as I said before, context is a key foundation for threat hunting, but at the same time, you can't be expected to know every host, every user in your environment. So this element of the notebook really kind of helps add some context for the hunter as they're going through. The other nice thing about this notebook is that it's combining data from multiple tables and sources within Azure Sentinel. So rather than having to write 3 or 4 separate queries to get this data, I can combine it into this one cell and bring back just the elements I want to look at. In addition, what we have done to kind of save on the amount of code that is required is produce a Python library called Mystic Pi that simplifies all of this data connection, collection, analysis, and visualization. So you'll see here that effectively that one line of code that I've highlighted, I'll just zoom in on it, is allowing us to execute a query against Azure Sentinel. So whilst if you're doing this from scratch with Python, you might need to write several hundred lines. We've simplified the process for you. It also means that you can customize these cells as you like. So if I wanted to change the query that we're running, maybe the time windows, or add a filter into our query, again, I can easily do that within this interface. I can also get details around other things. So here, the Azure subscription that this resource is running in. And I can also get some of the same data that you might see natively in Sentinel, but display it in a different way. So here, we've taken all the alerts for this host that we are interested in over the last time window, so that week. We can see that we have a whole number of brute force attempts, and we can see how they fall across a time period. Now I can zoom in on these, I can look at a bit more detail, and this can be really useful for understanding patterns that are going on. So those brute force alerts I saw, are they normal? Are we seeing them regularly? Well, it looks like it in this case. Maybe that is indicative of normal activity, maybe it's indicative of anomalous activity. Also drill down maybe into those alerts to get the details again of specific alerts. And again, I could do all of this from Sentinel itself, but the advantage of this notebook is that I'm doing it all in one place. And this is all set up for me because we've pre-built some of these notebooks for you. You don't have to be a developer or someone with advanced coding knowledge to create them. Simply load it, and as I'm doing here, run these cells and pick what I'm interested in from the graphical widgets. I can also continue down this notebook, adding in various elements to my investigation. So here, again, I've got a timeline, but this time looking at logons. So before we were looking at how did the successful logons fall with all of those failed logons or attempted brute forces that we saw. Seeing it here in a timeline, we can much more easily see that we have a whole number of failed logons over an extended period, but we have only the one successful logon. We can see it is from this one particular user, this TD, whereas if we look at the failed ones, we're seeing them from a whole bunch of users. So root, admin, more root, pi. Again, anyone who's exposed SSH to the internet before will be fairly familiar with this pattern of failed logons. We can also do nice things like map out where these logons are coming from. So red here are the failed, green are the successful. Now, this is a really nice way of spotting potential anomalies on logon data. Is this suspicious? Is this what I expected? Is this normal? And again, as someone who's based out in the US, I'm not really expecting a successful logon from Korea, as we're seeing down here, south of the border, but still a strange location for us. You can also expand this out into other areas. So if we jump down, I can look at application data. So if there was a specific application that had been found as part of my hunt that was interesting, say SSH in this case, because that's where we're seeing the logon attempts to, I can choose to investigate that application. So here I can see log volume generated by that application over time. I can see it's very spiky. I can see I have this completely flat period. Again, this gives me a lot of different areas to focus on. I can also generate things like process trees. So here, what I'm doing is querying, in this case, audit D data to get process information. Again, I've avoided using audit D data up until this point due to volume, due to some complexity with it. But for generating process data, it's really the only viable source. But you can see by how long this query is taking that kind of log volume and speed is a bit of a limiting factor. But you can see I have a nice here process tree for SSH. Luckily, this is all looking pretty straightforward and what I'd expect for SSH. But maybe if I was hunting for attacker activity, where I suspected they might have exploited a vulnerability in, say, Apache web server. Looking at that Apache process tree might show me potential child process spawning activity that might be suspicious, might be warranting further investigation. So I've shown you kind of a number of different features there that allow you to hunt through your data. You can choose what works best for you. Personally, notebooks are what work for me. They're incredibly flexible, they're incredibly powerful, but the barrier to entry is a little higher. So maybe starting with logs on the investigation graph is a better place. Also, another great feature that you will want to use in your hunting experience is the hunting queries. So again, there might be hunting activity that you want to search or conduct on a regular basis. Conducting a manual hunt can be quite time consuming, particularly if you regularly don't find anything of interest. But what we can do is you can choose to save a particular KQL query as a hunting query. You can also use some pre-populated hunting queries that we've developed for you. And by coming into this interface, I can go up here and choose to run all queries. This allows me to simultaneously run all of these queries down here against our data in the 14 days in this case. And I can see if any of those queries had hits. So in this case, not many. This tells me that actually these hunting queries that have no results, it's not worth me digging into. But maybe here where we have 3 results related to rare Linux command lines, that might be a worthwhile hunt conducting at this time. So again, this gives you a way of regularizing, productionizing threat hunting. So it's not a time-consuming activity that takes an analyst a day or multiple days. It can be something you build into your SOC workflow to say, these few hours, half a day a week, run all of our pre-built hunting queries, select one that has some interesting hits, and focus on that one for those few hours. So again, once you've kind of conducted your activity, you're not fully finished with your hunt. Documentation, as I said, is really important, particularly as you're repeating hunts. You're going to want to document what you did, why you did it, what you found, what your next steps or outputs are going to be. And again, you can use things like bookmarks and record comments in there to help. But really, you're going to want something a bit more kind of comprehensive to be able to record this activity. So something like this that kind of shows what you did, when, against what environment, what your queries were, what the outputs were, what you found, so on and so forth. Again, you can choose what works best for you. It might be a formal Word document. It might be a shared team OneNote. You could probably even use a Teams channel to record this activity. One of the things I've recently been working on is the idea of using a notebook to kind of produce this data. So again, as I like notebooks and I want to work in them, can I get them to do my documentation for me? So again, because this is just Python code, I can create this notebook here that is effectively producing the report for me. So it asks me a few pertinent details. It runs some queries for me, produces some results, records all of this to a document. This is not a great threat hunting comment, so please don't use this as a good example of a report, just for this scenario. And what I can do now is jump into this, and it's pre-built a report for me. It's populated the environment I was working at the time, my name, the query I ran, the results, and my comments. I've not had to type anything, it's just built it as I go. So again, the value of notebooks is that you can start building in other features like this. And again, I don't have to use the notebook to write to a Word document. I could use it to update tickets in ServiceNow. I could use it to write to another format, however you want to document your threat hunting activity. Now, the final thing I want to talk about before we come to an end is where do you go from a hunt? What if you don't find something, or if you find something and want to productionize it? Well, the obvious thing to come out of a threat hunt is new detections. You hunt for something, you find some interesting activity, you want to set up a detection to find it next time. The challenge people often face with this is they will take their hunting query that found this interesting item and just turn it into an alert rule. But more often than not, a good hunting query is not a good detection. Instead, I would recommend going back to basics and looking at the problem from scratch and say, are there other data sources we can use? Are there other points we could detect this activity? So again, if your hunt has detected a piece of malicious activity at a later stage in the kill chain, maybe could you create a detection that detects that activity at the start or earlier down the kill chain? You also don't have to make everything a detection. By having those hunting queries that we can save and easily run on a regular basis, we can leave some of those detections or those hunting elements as hunting rather than alerts. You don't have to make everything a detection straight away. Using the hunting queries or the new live stream feature we've added as a kind of testing ground for alerts can be good. So maybe consider making your new detection a hunting query for a week or 2 weeks, run that hunting query every day and see how many alerts or how many hits it's triggering. If it's 1 or 2, maybe that's worth creating an alert for. If it's 110,000 every day, well, you know that you've got a detection that you definitely don't want to put into production. So again, don't just jump from, hey, I found this using this hunting query, let's make it detection. Go back, kind of think about how you're going to build a detection as you go through. So we've covered kind of a lot of different elements in a very short space of time there. So a few kind of things to focus on as you take away. One is when you're developing your hypothesis, put some time into it. If you are not sure about what to hunt for, use the community. There's some kind of really useful research and ideas out there. Make sure that you use all the different features of Sentinel that work for you. Don't limit your hunting just to the query viewer. Use the investigation graph from a bookmark, use notebooks, use really kind of what works for you. And again, what works for you might not work for the analyst sitting next to you. So remember, you've got that flexibility. Document, always document. It's the thing that hunters like doing the least, but it is probably the single most important part of this. And also remember that hunting isn't a one-off activity, and it's not an activity exclusively for your tier 3 or senior analysts. You can use things like notebooks and those saved hunting queries to bring junior analysts into your hunting, and also maybe even non-security staff. Bringing in IT staff or even end users to your hunting activity on occasion can be a really useful way of getting a different perspective or a different context to what you're looking at. So maybe running a host notebook and showing that notebook output to that host administrator and say, does anything about this data look suspicious to you, can turn up some very different responses to a security analyst who's not touching that box on a regular basis. So with that, we've kind of reached the end of today's content. I hope you've enjoyed it. Please, if you've got any questions, keep them coming in. And again, please, if you have any feedback about Sentinel, the hunting queries we've produced, notebooks, we'd love to hear it. And we'd love to hear how we can continue to make threat hunting easy to access and effective for our customers.
Great, thank you for that, Pete. So now's the time when we'll raise questions that come in verbally back to Pete. So this is a great time. If your question is something that perhaps isn't best answered in a quick answer through IM and it's something you want to hear Pete kind of expound on a bit, it's a great time for that question. So everyone, if you have questions like that, please submit them here. I'm going to start us off with a couple of ones that came up and that are especially applicable. You mentioned that the notebooks are great for documentation purposes. Do you find they're also useful for perhaps if you discover an incident and transitioning to the incident response process?
Yes. They're really good because they have a whole kind of path of what you've done. You can see all the queries run, you can see the output. So if you have to hand off your investigation to another team, maybe as part of that IR transition, being able to hand over the notebook so that they've got a record of everything you've done up until that stage is great for their understanding and saves them time. You don't have to explain, oh, I ran this query. And again, if you're heavily using the query pane, you'll quite often end up with 20 or 30 different tabs with different queries, and even remembering yourself quite what you ran when and what you found where can be tricky. Whereas the linear nature of a notebook makes that much easier.
Great, thank you. I know we share some examples of our queries that we use or that we think will help the community. Can you tell us a little bit about how people can get those?
Yes, so all our queries are shared on our GitHub site. So if you search the Azure Sentinel GitHub, you will find the raw queries, some of which, or most of which are pulled through to the interface, but there are others on there. And again, I would strongly recommend that you check that out. And if you develop some interesting queries of yourself that you want to contribute back to the community and other users, we're very keen to get contributions into that GitHub. So please feel free to add elements, raise issues. In addition, pretty much most of the Mystic team working on Sentinel here is on Twitter. If you find us on there, people are always sharing kind of tidbits of things that they found interesting, occasionally some query snippets and things that could be useful for that.
Okay, great. So often these queries can end up producing some pretty sensitive data in the output. What are options for protecting that?
So again, notebooks provide a really useful way of protecting particularly sensitive either the data or the analytics you're running. So we have Azure Notebooks that allows you to run these notebooks in Azure, but actually you can run them locally on your host. So what you could do is run the notebook on a local secure system, pull the data in and do the analysis that you want, and then save and store that notebook and the output and the data locally in whatever secure environment you would like. In addition, if you're running a query and that query maybe contains sensitive data, let's say that you want to see if a password has accidentally leaked into logs, but you don't want a record of that password being kept. What you can do is prefix the password string you're searching for with the H letter, and that redacts it from any kind of metrics or auditing logs. So it doesn't necessarily kind of fully hide the query, but it hides specific elements of that query. So again, if you go into the query pane in Sentinel, you'll see a list of previously previously run queries, you might not want certain elements of that to appear if they're particularly sensitive. So that H before the string obfuscates that.
Okay, great. We had someone wanting to clarify here. Are these Jupyter notebooks now available to everyone to use, or is this something that's in preview?
No, they are available to everyone. So if you go into your Sentinel portal and select notebooks, you should see them there. Gotcha.
And if, say, one of these Jupyter notebooks were to get exfiltrated, is there anything that can be done to protect against that scenario?
So the notebooks in their kind of raw format are not sensitive. Obviously, once you've populated them with data, they are. So the kind of the base level of a notebook is a JSON file. So you could apply protections to that kind of raw file as you would like. So it's not my area of expertise, but I believe Azure Information Protection would allow you to classify and protect that file if you so wished.
Yeah, that's a great point. And for anyone who wants more detail on that, I've got links on our community landing page to Azure Information Protection, and we can take the question to that forum if you want to dive in more detail there. What do you find to be the most difficult or time-consuming part of the hunting cycle?
So for me, I find the cycle starts slow and speeds up. So your initial stages of finding the data that you want, cutting out of all of the kind of day-to-day noise and just getting down to anomalies or really interesting things is the slowest part. So again, as you keep working in a environment, documenting what data you found, what's in it, using that matrix that I showed earlier, really helps kind of save time on that kind of element, that slow element of the hunt. The other thing that I found has slowed me down in the past, kind of why I stress documentation so much, is there have been times in the past where I've spent several hours on a hunt, found something kind of interesting, turned to my colleague, only for them to say, "Oh yeah, I found that yesterday." That is obviously a huge kind of time suck, and hence why I feel documentation is so important.
Great, thank you. With knowledge being key, as you mentioned earlier on in the presentation, and kind of expertise around this threat hunting, is this something only larger teams with very diverse kind of knowledge, skills, and sets should take on, or should smaller teams take this on and just perhaps modify their approach?
Yeah, I would encourage smaller teams to spend some time on this as well. Not every organization is going to have a dedicated threat hunting team, but if you can carve out a day, half a day a week for your analysts to spend doing some hunting, not only will you find some interesting things, you will also end up upskilling them because they will have to do some research into this. But you'll also find that they gain a knowledge, context, skills that will feed back into their regular instant response or security monitoring roles as well. So it's really something that kind of adds value back into the day job if you're not doing it as a full-time hunter.
Excellent, thank you. We're about out of time here, so I want to give people a couple of reminders. We're always getting asked about the recordings. You can find the recordings at aka.ms security webinars. I'm going to post some other links here too if you want to post questions offline to our community. The link I'm posting now is a great place to do that. And if you want to just join our security community in general, which includes Azure Sentinel, but is also broader, it's basically all of our security products, you can do that at the link I just posted there. I want to thank you, Pete, for a fantastic presentation. Thanks to all of those online here on our side who helped answer all these questions. And of course, I want to thank all of you for joining us, and we hope to see you next time.